Take a moment to pause this video and read the full problem statement. I'm going to focus on parts B and C using StatCrunch. So here in this example, we're told to use the normal model. And again, I'm going to start here on part B. What is the probability that a random sample of n equals 40 oil changes results in a sample mean time less than 15 minutes? And because I have a sample of 40, what that's going to do to my given standard deviation up here is I'm going to have to take that standard deviation, 3.8, and divide by the square root of 40 to get the standard deviation that I will use in StatCrunch. So let me bring over my StatCrunch screen. And here I'm going to go to Stat, Calculators, and Normal. Let me move this over just a little bit. So this is where I type in that adjusted standard deviation, and I'm getting, when I do that calculation, 0.601. Again, that was 3.8 divided by the square root of 40, and I'm just rounding to 3 decimal places. We're told that the mean time is 16.1, so we'll include that here. And we're asked to see the probability that we're looking at a time less than 15 minutes. So less than 15 minutes, and I'll click compute, and that's how I get the probability that was requested in part B using StatCrunch. Now in part C, I'm actually working this backwards. If you read this problem statement, really the $50 doesn't make much difference. The timing doesn't make a lot of difference. But notice that you're still looking at 40 oil changes, and you're treating that as a random sample. So I'll keep that same standard deviation that I had earlier. The difference here is I'm asked what would be the time if I'm looking for a probability of 10% or less. So I'm going to come back to StatCrunch, and this time I'm going to change what I have for the actual calculation for this probability to 0.1, 10% or 0.1 probability. Then when I click compute, I see that time here, that the probability that x is less than or equal to 15.3 produces the result of 10% or less.